Hi, I'm Andrew Armstrong. Welcome to the back office. Today's episode, I guess, was technically sponsored by Steve Fisher, Techbeachinc on Twitter. He's a very cool guy, and look, I've even drawn a thumbs up. And he sent me a package containing a few items, and I'm just going to show you what was in them because it's rather fantastic. Look, first things first. This is what we'll be doing today, by the way. He sent me this kit which he worked on, which is an electronic dice. And look, it's actually quite a good quality one. It's not like the kits I normally get from China with no instructions. This is a legit kit that I'm guessing he bought in Maplin or somewhere like that. But it doesn't work. So we're going to have a little check out of that in a moment and see what's going on with it and hopefully fix it. Also, a bunch of different colour LEDs. And this is kind of quite useful to me because, of course, I have only surface mount LEDs, so actually having physical LEDs that I can mount through hole are really crazy useful. So that's going to be great. Thank you very much for that, Steve. And this is something we're going to cover in a future episode because it's obviously an amazing, amazing thing. And as you can see, it's a console de jeu sans fil, which means, I don't know, games console sans fil. Phil, is Phil's sister? Without your sister? Without part? I don't know what it means. But it looks like a Wii clone. One of those terrible, terrible Wii clones. So, this is going to be a good one. We need to make sure that we have a nice TV setup for that one. So without further ado, I'm going to turn on the soldering iron because I'm going to assume we're going to need to do some soldering. We're going to zoom right in. We got our battery. 9 volts. Velman kit. These are great kits. I remember them from like when I was a kid. So they've been around for a hell of a long time. Battery in. And yeah, nothing. Nada. Let's try again. I think I briefly saw something flash. Yeah, did you see it right there? Those 3 LEDs on the right hand side just very briefly flashed. So let's look at the kit here. You've got a very tricky to see actually. This is a CD4024BE. 2 of those, but they both say that. But so the actual line on the top is a 19 ANK and a 25 C5 JTK. Gosh knows what they are, but I'm guessing there's some sort of decade counter 555 timer combo, which generally is the way to achieve this. And then you use certain combinations of diodes, as you can see here, and that'll give you the various patterns that you'd expect on a die. But looking closer on the board, I can already see what I believe is the problem. Yeah. Diodes can only go in one way, and they've got a line on them, and you can see this black line on the very end. In fact, let's try super zoom. Look at that. So that diode, black line on the very end, tells you which polarity it is, but you see the PCB also has a very dark white line on one end of that symbol, and that's telling you that should be in the other way round. So that's a bit tricky because we've got to take off the battery snap and everything, but we've got the tools, we've got the power. Let's just crack on and do it. My soldering iron, by the way, is on and hot. I've got it set to a whopping 480 degrees because I tend to like that, tip oxidizing, searing heat that allows me to sort of almost damage anything I touch with it. So thanks for people who suggest otherwise. Okay, let's just see something on the back here. I think when the camera decides it wants to look at it, we've got an interesting little bit of solderage there going on too. So we'll just touch up some of these as we go along. That actually happens to be, I think, one of the legs of the diode. Not quite sure. We'll work that out. So I think the main issue with this PCB, looking at it, is it probably just didn't have enough heat applied when it was being soldered up. So don't be afraid to use a bit more heat if you've got it. Got a bit of a solder bridge situation there going on with these. So there is enough solder there. There's certainly enough solder, if not too much, but it's just not where you want it to be. Touching these all up. Sorry about that jump cut there. I heard a lot of screaming from outside, and those of you who are parents know how kids just seem to drive you nuts doing such things, so I had to check that out. But it was all okay. Just kids being bloody kids. Let's just keep cracking on with this. I think I'm going to need to grab some solder braid. I think the only solution for us is to actually clean off some of these and start again. We don't have the circuit diagram, so we don't really know what we're looking at here, so let's clean it off. I can't tell whether or not these things should be connected or not. I think they probably are. That's just the battery power, so it'll be coming through those things. Another battery snap. Because all of these ICs here are very very dry. I'll turn it at an angle, might be able to see a bit better. Touch them up, that's what we do. There we go, that's better. Just a bit of heat. If you're doing it again, Steve, just hold the soldering iron on there for that touch longer and it'll be good. You'll see it flow. Don't worry about holding it on there for too long. You won't be able to damage it really. There's not too many components on here that'll damage from excess heat, because of course the ICs are using a sort of chip carrier. Just going to put a bit of braid now on here. In fact, forget the braid. I'm going to use the solder sucker. I think some of you have got one of these that you've got in your Christmas presents as the sort of generic electronics hobbyist kit, but they do the trick on these through hole things, so it's fine. Just go ahead and use it. There's no shame at all. Right, so now we've dried those off. I'm just going to put a little bit more now so we can get a nice fresh connection. Finally, it seems all is well in the world, because there is silence from these screaming children. Again, as a parent, that's a warning sign that something is going to go down. They're clearly plotting something, and we'll hear a cacophony or a scream in a moment. A few more dry connections, but that's okay, we'll just get in there. Now you have to remember, because a lot of the solder that's being supplied with the kits or solder you're buying now is lead free, which means you're going to have a lot of issues in soldering, because one, you can't quite see when it's wetted, and two, it's quite a fragile solder bond. In fact, I read somewhere that they reckon shifting to lead free has actually caused more landfill because of failed PCBs than ever before. So lots of devices that had never ever developed a fault, once they sort of shifted to lead free, even with the same designs, loads of faults. So yeah. Right, good. So that's just the basic soldering out of the way. Now we know we have to extract some of these diodes, so I'm just going to have a quick look. That's good, that one's good. It's these three, this trio here. Trio at the top of this board, right where my finger is, so we'll be able to just grab those up. Again, oh, the solder sucker is jammed. I'm just looking. Backup solder sucker. I'm clearly not cleaning out my solder suckers adequately between suctionings. If you've got one, to clean out the solder sucker, you just unscrew the end of it and shake out all of the collected solder. This board's trying to escape. It's for your own good, trust me. I'm a doctor. Right. One more. Let's see what we can do with this then. So the diodes have had their solder removed, but it never really gets rid of all of it. So you're going to have to, you can see here I'm sort of got my tweezers and I'm just going to give it a little touch. There we go, one out. There'll always be a tiny bit holding it somewhere on one of those pins, and you don't really want to force it. You don't have to force it. So two. Third one's a charm. Yes, there we go, all three out. Just gonna clear the decks. Come on, boys. Get over there. Got them. So let's have a look. Let's zoom in for a nice close-up. So you see D1, D2, D3. That's the way to do it. Ah! Of course it helps if your tweezers let go when they should. So get that in there. Just trying to work this other end in. You'll find that because they've been cut, you can... there's a combination. They've been cut and the holes have been sort of closed up because of all the previous solder. Remember, these are often through hole plated. So you've just got come on, stay in there. Right, tell you what, I'm just gonna tack solder that as I go along because I'm not gonna want to mess with that one anymore. Come on, bit of solder, that's what I need. There we go. That's fine for now, not going anywhere. We'll touch those up in a moment. D1 then, D2. So diodes only let current flow in one direction, so it's basically a one-way valve. I'm trying to think of an analogy between things you have in real life and different components. So I'm guessing a diode is a bit like the valve on your car tyre or bicycle tyre. Come on, you bugger! Only a little bit more annoying. Right. In. Nice. Finger on the back. Give it a good old push. I'm going to get a blig piece of solder. A blig piece of solder. And I'm just going to work it. So you can get a little blob of the solder on the end of your tip and just drop it on. Just deposit it where you want. That works pretty well for this sort of bit of rework. And then if you want to do a nice proper job, put it down afterwards. Keep the soldering iron by the end of the component and just dab a tiny bit of solder on there. That's going to flow. It's going to flow real nice. So I think that's pretty much it. I'm just going to get some side cutters from somewhere. Who's been at my side cutters? There they are. Trim that off because we had a little bit of spare leggage. Let's just check this. The ICs are in the right way. This diode is correct. Correct. This is an electrolytic capacitor. Negative is this side of the stripe and it's on the negative pad because I'm guessing this is the positive. Actually, yes it is. I can see underneath there's a positive there too. That's correct. Resistors are resistors. Can't really check those. They can go in either way, and this capacitor, this small ceramic, can go in either way. So far, looking good. Transistor there. Again, transistors marked quite clearly, can only go the one way. So I would care to guess that if I put the battery on, ooh, look at that. Nice. Let's turn the soldering iron off because it's a bit of a noisy one in my ear. Screw this back together. And then let's have a little run through and try to work out how this goes down. I guess it doesn't need to be too hard, really. Good. Battery in. Look, it's quite a nice snap, really, isn't it? It's good. It's like a little module. It's not going anywhere. So you've got the center light on telling you that it is powered, and I'm guessing it just stays like that forever. The light will be on. Hit this. See, it's jiggling, flickering, and then it's settled down on the 5. Jiggling. Setting down, oh no, on a 6 that time. Ooh, and a 3. So that's good. It is kind of doing dicey type stuff. Just going to see if I can kind of sketch out how I think this is kind of working. So you've got a 555 type timer normally. You've got a decade thingy. So every time it gets a pulse, this isn't a wiring diagram, by the way. This is just a very crude thing. So imagine you've got I'm just going to draw them like bulbs as well, the LEDs, because I don't want you to think that this is any way a schematic. So what happens is basically you've got your push button here, which you hold down. The push button then will charge up a electrolytic capacitor, which you saw right here. That's charging up, and then once you let go, this capacitor, I think, drains down. And it's also part of the timing circuitry. Okay, so I'm going to draw a little clock, a little timing circuitry for that. So as it sort of drains down, it actually affects the speed. So that's why you get it. It's very fast, and it gets slower, because there'll be a capacitor resistor type timing thing going on with that. Every time the timer sends a pulse to this counter, it'll turn on the next one. So first it goes click, 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 click. So if you didn't have it wired up in a particular pattern like this, it would just go zzz, and then just stop on one, zzz, on one. So what they've done here, to get the effect of the different colours on the die, you'll know that electronic dice, or actually a dice on any kind of die, can be made up of this sort of matrix. It's a 5. So you've got certain combinations. So you've got 1 in the middle. 1, 2, 3, 4, 5, and 6. Okay, so they've just wired them up in certain ways that 1 on this decade counter will obviously light up just the 1. 2 on it will light up these 2 LEDs. 3 will light up these 3. So you can imagine it's quite complicated. There's a lot of little logic going on with these diodes. So that's why those diodes are there, just to give it a little logic to sort of make it actually work. So if you're using a micro in these days, you just have one single tiniest micro and nothing else. You don't need anything else, basically. You could even hook the LEDs almost direct without even resistors if you're only pulsing them very quickly. So that was actually quite a bit of fun, really, and that, in terms of its kit, this Velman kit is a pretty good kit if you want to learn how to solder. Just take that care, make sure you don't, you heat the component area nice enough. Just have a quick look in here. Oh, look. Wowee, it even has instructions. That's pretty damn good. Oh, after all my time spending talking the sort of nonsense to you, working out how it is, but look, there you go. So there's your, this is called a phase lock loop here, but effectively imagine it's a thing that's pulsing, creating a counter. You've got this VCO out going to the clock in on the decade counter. The decade counter's counting up to, well, look, it's only using 3 of those, actually, isn't it? So it's basically almost binary at that point. It's ignoring all of the rest, and they're going up by the different diodes and the transistor to the different LEDs. And look, the transistor's obviously flipping it over because some of the combinations need an inverse. So there you go, brilliant. Copy the circuit, you got it all there. Nice kit. Please comment down below if you've got any experience of these kits and you've had a go. Like and subscribe if you're that way inclined, and as ever, thank you for watching. Almost forgot. Another success. Great success!